Okay, good afternoon. So let us now, or good morning. Yeah, let us continue the lesson of differential equations. So if you remember, we discussed about how to solve these differential equations last time. We learned that the method of integrating factor is the most general way to tackle the problem and we can solve it. But then, of course, I told you that if you want to use that method, then you need to be able to find a primitive function for a product, which is not usually the best way. Most of the time, it's not the best way. Uh, then we learned that we have another method called the method of undetermined coefficients, but that also doesn't work for all cases, but it works for the cases that f of x have three forms. I mean, either polynomial or exponential or a mixture of sine cosine functions. Yes, sine cosine. You're right. Okay, but how? What was the algorithm we were using? So I told you that if you want to solve that using the method of undetermined coefficients, which is suitable only for these cases, you write, you solve the homogeneous one. The homogeneous one is this differential equation in which the right hand side is equal to 0. Essentially, you don't need to do anything at all. We hopefully I was able to convince you that the solution is always a constant e to the power of minus ax, and I think this is also in the formula sheet. So this part is easy. But to emphasize that this is the solution to the differential equation, which is the homogeneous one, I equip it with some index h. And number two, we write if we find a particular solution, determine a particular solution which we call it y sub p of the original differential equation. And number three, the solution, the general solution of this equation that I'm looking for, I prove that it becomes y sub h plus y sub p. So this is the algorithm that we want to use. The first part is always the same. The last part is just adding the answers from the first and the second. So the problematic thing in this algorithm is just number two. Okay? And then I want to give you more examples today. We solved one problem in which f of x was a polynomial. So let me start again from here and then continue to this to see what happens. Okay, so let me give you an example. So in the following, we want to find the general solution of the differential equations that I bring here. So the first one, let me give it simple one. So a y prime minus 2y equals to 3x squared minus 5x plus 1. I hope that you agree that this is not simple to guess. I mean, even though this differential equation looks very simple, but we are really doing something even using this algorithm here. So the first thing that you do, you just put this equal to 0 yourself, and then let me put bullet points. So the first one, and then this is already clear. The answer y sub h becomes a constant e to the power of minus a times x. By the way, this algorithm works if this coefficient is 1. If the coefficient is not 1, you have to divide by 1 first. I mean, only the first part. The rest of it is not very sensitive to if this is 1 or not. Okay, so e to the power of minus a times x. A in this problem is minus 2, so minus a becomes positive 2x. That is the general solution of the homogeneous part. But for the second part, I want to determine a particular solution, and that's important to understand the logic. Just one single solution is enough. So there is no best solution. You don't need to work hard. You just need to find one solution. Okay, but then do you remember what was the idea behind the method of undetermined coefficients? If I want to look for a function who fits this differential equation, it is pointless to look around all possible functions, yes? Because I want a function whose, if I multiply it by -2 and add it to its derivative, it becomes a polynomial of second degree equation. So for example, there is no point in looking around in the toolbox of trigonometric functions. Because if y is a trigonometric function, this combination definitely becomes a differential trigonometric function, and it is not possible to become equal to a polynomial function. So by the same logic, so what would be the best guess for y? A polynomial equation. Yes, it should be a polynomial, but even polynomials are very broad. I mean, but I only consider the second degree ones. Yes, because I don't need to go even to higher degrees. If I go to higher degrees, say 3, then the derivative becomes second degree, I agree. But this one is the third degree, so it remains a third degree polynomial, which is useless because I need only the second degree equation. So what I need to do, I need to find a second degree polynomial that fits in this equation. And the most general one I can write is ax squared plus bx plus c. Okay, so these coefficients that are not determined are called undetermined coefficients. And then what I need to do, so this was a guesswork. It's a combination of guesswork and analytic work. Analytic work, part of it is that you don't need to guess A, B, and C. You can calculate them systematically. So by putting this back into your equation. So if I want to put this back in my equation, I need the y prime. So I differentiate this, so it becomes 2ax plus b, and then I put them back into this equation. So what happens? So it becomes 2ax plus b, and then I will have minus 2 times y, which is 2ax squared, but this minus 2 is just for this one, for all of it. So it becomes minus 2bx minus 2c. This is the left-hand side, and the right-hand side is supposed to be 3x squared minus 5x plus 1. Yes? Okay, and then I organize the left-hand side. So how should I organize that? I will take this one, write it first, then I see that there are 2 places that x appears, so I factor it out. I can also factor a 2 out in this case. I factor a 2 from the left and x from right, so it becomes a minus bx. And then one constant here is left, another constant there is left, so it is minus 2c, b minus 2c. This is supposed to be equal to this polynomial. And as I told you, the logic is not to find all possible answers. I want just to find one answer that I am sure it works. Okay, so in order to do that, I would say that this coefficient is the coefficient of x squared. So it should be the coefficient of x squared on the right hand side. And then the coefficient of the x should be equal to the coefficient of the x. And the constant number should be the constant number. And that is enough, because if you see, there are 3 unknowns for me and there are 3 equations. So in principle, I should be able to calculate it. I don't need to do any guesswork anymore. So I calculate a from the first equation. A becomes minus 3 over 2. Then I put this number here. So let me divide everything by 2. And I replace a with this number. So it becomes minus 3 over 2 minus b is minus 5 over 2. So b becomes a 1, yes? So b is 1. A is minus 3 over 2. And then I go here, c becomes 0, because b is 1. I put it in the last equation. So this means that c is 0. Okay, so if A is this, B is that, and C is this, so I can write my particular solution by replacing these numbers into this formula. So this becomes minus 3 over 2x squared, and then I have plus x. That is the solution that I was so I was able to derive that. So I did a little bit of guesswork. I guessed this general form, but I didn't guess anymore. I just calculated everything. Now I need to go to the third part of the algorithm. So the third part of the algorithm is just nothing, just add them up. So y, so this is the answer that you have to provide for this problem. Y is yh, which is on the board. It is ce to the power of 2x. And then I have plus yp is 3 over 2x squared. And then, of course, plus x. This is the general solution of this differential equation. And I hope that you agree with me, even though the differential equation was not hard, but it was not easy to guess this answer. If I remember correctly, there is also, it's good to know, yes?
Isn't the second term negative?
The second term? Ah, yes. It was minus, yes, thank you. So, because when I use the solve on GeoGebra, I see solve ODE, so it should be differential equation. Let us check also as well. Okay, so now go to this one. If you press solve, yes, so ODE is differential equation, yes. O means ordinary, because we have two types of differential equations. One is called partial differential equations that are related to differential equations in which your function is a function of more than one variable. Except for that, it is an ordinary differential equation, so you just use this. Okay, so this one we want to use, solve ODE equation. And if remember correctly, so the equation that you need to type is your y prime. So you see here, I cannot type the differential equation. So my differential equation is this differential equation, but in GeoGebra you need to type y prime. So it means that you need to move this to the other side in your head. This becomes this plus 2y. So this plus 2y is what you need to type in, if I remember correctly. So let us do that. So what I will do, I will type 3x to the power of 2, and then I have minus 5x, and then I have plus 1, and then I have plus 2y. This is what, oops, why it came out, I don't know. So I go back again, 3x squared plus 1, and then plus 2y. This is your y prime. Yeah, that's correct. So this is the answer to the differential equation we got there, yes? But I don't know, for some reason they write C sub 1, but there is only one constant in this problem, so you don't need to write C1. Yes? So it solves, but I don't think it should be very strong. So that's it. That my idea was correct. If you want to type a differential equation, probably only of the first order. I don't know if it can solve higher order differential equations, but at least for our case, it is good enough. Okay, that's it. Now we want to just give more examples. So I solve this problem using for polynomials. Let us give some examples for exponential, sine, cosine, and if we have more time, we can delve a little bit more into more interesting problems. So the next part, let me write this, for example. I would write y prime plus 3y equals to 6 e to the power of minus 2x. Okay, so this is one of those cases, if you remember, the method of integrating factor is actually very useful. Okay, so let us solve it in two different ways, because if I want to use the method of integrating factor, because the right hand side is also an exponential, when I multiply two exponential, it doesn't remain in the form of a product. They will be absorbed into one another. So let me write method 1 here, which of course is faster, integrating factor. I want to use it, so, but I don't know if you remember what is the integrating factor. It was always the same thing, e to the power of ax. A in this problem is 3, so my integrating factor is e to the power of 3x. So you multiply both sides by e to power 3x. This is what you get. The left-hand side is always the right-hand side of a product rule, the product rule of this function. You can double check this one multiplied by the derivative of the second one plus the derivative of the first one multiplied by the second one itself. But you see that even though it is a product, but they can be absorbed into one function now. It's simply 6e to power x. So I would recommend you, if that is an exponential function, might be the method of undetermined coefficient. Of course it will work, but might be the method of integrating factor is useful, or is faster. So I ask myself, what is this? So let me write all the details. So do you remember we introduced this symbol for primitive functions? So this becomes e to the power of x dx. But that's an extremely simple problem. What is a primitive? What are the all primitive functions of that? 6 goes out, the function repeats itself, and then you have a constant c here. In order to find y, I multiply everything by e to the power of minus 3x, or in other words, I divide everything by e to the power 3x. So this becomes c e to the power of minus 3x plus 6 e to the power of minus 2x. So simple as that. So this method of integrating factor works fine. Okay, now method of undetermined coefficients. Okay, so if I want to do that, so for method of undetermined coefficient, the first thing I have to do, I have to solve the homogeneous one, but we know the formula for it. So y sub h is c e to the power of minus 3x. This is the homogeneous one, and you can see that this is revealing itself here. Okay, and now I need to find a particular solution. Okay, so what is your guess? Because you need to do some guesswork and some analytic work here. So what is your guess for the function? I want a function so that 3 times the function plus its derivative becomes this exponential function. So what is the most general exponential, what is the most general function that you can dream of? Yes? What?
For an exponential function, that would be.
No, I'm not asking you to guess exponential. I'm just asking you what is your idea about this function.
It's going to be an exponential function.
Okay, so what exponential function? Because there are infinitely many exponential functions.
Well, the most general form here would probably be e to bx plus c, I guess.
E to power?
Bx or no.
No, you don't need to make their life hard for yourself, because I told you that you don't want to find all of them, you just need to find one of them. So if I give you an exponential with a different coefficient, it doesn't work, of course. Because if I give you e to power 3x, for example, then it becomes e to power 3x. The derivative of this one is still e to power 3x. So the combination of them will be some e to power 3x, not e to power minus 2x. So I don't need to make life hard for myself for no reason. So definitely I will choose the same exponential. Yes. But of course, I should be very extremely lucky that this one exactly works. Because I don't have that guarantee, so I put one undetermined coefficient here to fine tune that A. Okay, and then if that's the case, I differentiate this. Minus 2 goes down, e to power minus 2x. And then, of course, I did some guessing. This is my guessing, but I'm not guessing A, I am calculating A. By putting these two back into my differential equation, so y prime is this expression that you see, minus 2a e to the power of minus 2x, and then plus 3 times y, this is my y, so I multiply it by 3, e to the power of minus 2x. Yes? And the right hand side is 6 e to power minus 2x. And then you see that I can combine them. I have 3a of this expression minus 2a of the same expression, so it becomes 8e to the power of minus 2x. And this is supposed to be 6e to the power of minus 2x. And then by comparing them, you can see that a should be 6. When a is 6, so yp is clear. Yp is 6e to power minus 6x. And then I need to find the sum. So the answer that I provide here is this answer plus this answer. And then as you see, they are the same. Yes? Okay, so that's an example for exponential functions. I told you, for exponential functions, you have two methods working. Yeah, questions?
Why is it 6e to power minus?
Oh, okay. So let me see. No, that was a stupid. I don't know why this becomes 6. This is a still 2. So then I am writing any number that I like actually. Yes? Yes. Yeah, that one should be that. Yes, that's correct. Thank you. Okay, now we go to another one, which is sine and cosine function. Okay. So you see, we talked about polynomial, exponential. Let us go to this part now. Okay, so we have, for example, this equation, 2y prime plus 3y equals to 2 sine x. Okay, we want to solve this differential equation, find the general solution. So what we do first, again, I go to the homogeneous one. But to solve the homogeneous one, using the formula we derived, we have to divide by 2. And then the general solution for that is c e to power minus 3 halves x. So here it is important to divide. But for the rest of it, it is not important if it is 1 or not. You try to guess, but that is important what to guess. So I need a function so that it is probable that if I put it back here, it generates a sine x function. So what type of functions you expect? Or what type of function? Yeah, it should be both of them in one formula. Because if you just consider sine alone, then the derivative becomes cosine. You don't have it. If you consider only cosine, its derivative becomes sine. It becomes a mixture of sine and cosine, but the right-hand side is just sine. So by this observation, it is better to put both of them into my guess. But then I have to fine-tune something to make this work. Okay, and then fine-tuning means that I put two undetermined coefficients here and try to determine those coefficients in a way that it works. Okay, but the rest of it is easy. For this part, you don't need to make sure that this coefficient is indeed 1. So you just take the derivative. This one becomes a cosine x. Cosine becomes minus sine. Now I take these two and put it back into the original equation. So this becomes 2 times y prime plus 3 times y on the right hand side. I will have 2 sine x. Then my goal is to fine tune and find one possible answer. Okay, so I expand that so it becomes 2a cosine x minus 2b sine x. And the other one becomes 3a sine x. And then I have 3b cosine x. The right hand side is 2 sine x. But then I want to write the left hand side in a way that I can compare the sides. Okay, so you see cosine appears in 2 places. So I factor a cosine out. Yes? Is there something wrong? No? Okay, and then between these two, I factor a sine out. And now it becomes easy to compare, yes? So I guess this one, the derivative is this one. I put them here. I expanded them. I organized the left-hand side. Now I start comparing. So the comparing is extremely simple because you see that the left-hand side involves cosine, but the right-hand side doesn't have any cosines. So it means the coefficient of cosine should be 0. And the coefficient of sine should be equal to the coefficient of sine here if I want to have this matching. So it means that minus 2b plus 3a should be equal to what? 2. So even though I guessed this, but I am not guessing the coefficients anymore. I'm calculating. So what do you think it's a good idea? So let us do it in our head. If I multiply this by 2 and this by 3, this will be gone. This becomes 4 and 9, it's 13. A is equal to what? I multiply this by 2 and this by 3, so it becomes 13, and this becomes 6. So A becomes 6 over 13. And if A is that, I want to calculate B. I put it here, move it there, it becomes minus 12 over 39. Yes? So these are the numbers. So I hope that you agree that guessing these numbers was not easiest.
Can't be simplified even further by dividing by 3, by factor of 3.
No. No, you cannot do that.
12 and 39.
Ah, okay, here. Okay. I thought that you want, because that's not general thing. I thought that you want to simplify the whole A and B. Yes, here you can. Yes, of course. I divide by 3. It is what? 4 over 13. Yes. So what you see is that even though I did a guesswork here, but it was not easy at all to guess these particular numbers. So this is a mixture again of guess and analytic work. Okay, and now I go back and write my solution. Okay, so what is the solution? What you need to provide as the answer to this problem is y equals to what? The yh, which is up there, c e to the power of minus 3 over 2x, and then plus this expression. Expression is plus 6 over 13 sine x minus 4 over 13 cosine x, and that's it. So I'm not sure if this GeoGebra can do that. Let us see. So solve ODE, but I told you that you have to type it in a way that that's y prime. So in your head, let us move 3y to the other side. So I move 3y to the other side, but I have to type for y prime, so I have to make y prime alone by dividing by 2. So if I do that, the first one becomes sine of x, yes, and then minus what? Minus 3 over 2y. So 3 over 2 minus 3 over 2y. I'm not sure. Yes, is that right? Minus 3, yes, it seems to be right. Where's my answer? 6 over 13. Yes, that's correct. Okay, so now let us work a little bit more here. So what do you think? I will give you one problem, wait for you, okay? So let me write this. Y prime minus 2y is equal to 5 sine 2x, and then plus 3 cosine 2x. Yes, so I will wait for you. Okay, could you solve it? Yes. Okay, so what we should do here is to write this one equal to 0 first. So y becomes what? Y sub h becomes ce to power 2x. And then what is your guess here? Hmm?
Y has to be a sine and cosine function, but the variable inside is 2x.
2x, yeah. So it should be a sine 2x plus, this is a reasonable guess. Yes? And then you take the derivative. What happens? It becomes 2a cosine 2x. Because of the chain rule, you have this factor of 2. And then it becomes minus 2b sine 2x. I put them back into the original equation. So this is y prime. It becomes 2a cosine 2x minus 2b sine 2x. And then I multiplied the function by minus 2. So I will do it just in one stroke. So it's minus 2a sine 2x. And then minus 2b cosine 2x. This is supposed to be equal to the right hand side, which is 5 sine 2x plus 3 cosine 2x, yes? And then of course I organize the left hand side so that the comparison is easy. So this one I have 2 cosines, so I take a 2 from the left and a cosine 2x from the right. And then I will do similar thing for sine. I factor a minus 2 out from the left and a sine 2x from the right, if my calculations are right. And then I compare it to the right hand side. Okay, so what happens here? The left hand side is a mixture of sine and cosine with the correct arguments. So you see that there's hopeless. It's hopeless if you just start with x. Okay, you have to start with 2x. So what should we write now? Minus 2 times a plus b, which is the coefficient of sine, should match with the coefficient of sine, and the coefficient of cosine should be equal to 3. Okay, so if you do it in your head, what happens? A becomes minus 1 divided by 2, yes. And b becomes what? If I multiply this by minus and add them, it becomes oh, I think I made a mistake, sorry. A plus b is, so let me solve it. I'm tired now. So a plus b is minus 5 over 2, and then a minus b is 3 over 2. So I add and then divide by 2, so it becomes minus 1 divided by 2 is minus 1/2, so that was correct. And then b becomes minus 2. Am I right?
Yes.
Okay. So then, of course, the answer becomes clear now. So the answer that you have to provide is the one that you got there, and then plus this by these combinations. So it becomes minus 1/2 sine 2x, and then minus 2 cosine 2x. Okay, and that is the answer. But GeoGebra, I accidentally touched the enter, so it gave us a little bit weird answer. Let us see why that is the case. So I already typed it here. If I press that enter, let me copy and paste this one. Might be I need this. So Control C. Okay, so if I press enter, I realize that it gives you a little bit strange answer. But I'm sure that this is not wrong. Yes. Yes. Okay, let me simplify if it works or not. Simplify. What is the function here then? So how can I do you know how to take this one and put it there? Oh, it worked. Okay. Miraculously it worked. I didn't know what did I do. But let me clean this y. And let us see if it can really simplify that. No. Okay, but I can see that that is correct, because let me write GeoGebra's answer here. So what I will do, I will factor, so because you know that this combination 1 plus tangent squared, I told you this is a famous, we had it in math 4, so that is the derivative of tangent actually, and this becomes 1 over cosine squared x. Okay, so if you write that, so here, if you see between this one and that one, I can factor this expression out. 1 plus tan squared x is left, and then the rest of it, let us see what we can do. Okay, so if I do that, so it becomes c e to the power of 2x, and then it becomes 1 plus tan x squared. And I don't know why we should do that. Might be the algorithm is a little bit different. So here, and then I have plus 2 tan x squared minus tan x minus 2 divided by 1 plus tan x squared. So that will be an exercise in trigonometry now. But you see that if I divide this by that, that factor is gone. At least the first part is correct. Yes? So this becomes c e to the power of 2x. But the problem is that I have to divide this by that. Yes? Then I have to convince myself that what you see here in terms of tangent is exactly that expression that you see there, based on sine and cosine. But let me make sure. Yes, we can do this to see if it works or not. So we have to convince ourselves if GeoGebra is correct or we are correct. This and that should be the same. Okay, but are they? Yes. So are they the same? Yeah, you can consider this as a problem in trigonometry. We want to convince ourselves that these two expressions are the same. Are they? Yes. So what we do, I start with this. What is your idea about to simplify that? Okay, for simplifying that, as just I told you, 1 plus tan x squared is a famous combination. It's 1 over cosine x squared. Yes? And then you multiply the numerator and denominator by cosine x squared, at least you get rid of the denominator. So it becomes, I multiply this expression by cosine x squared and tangent x squared. And then here I have cosine x squared, tangent x, and here I have minus 2 cosine x squared. The reason that GeoGebra probably gives you this answer because it's following some kind of algorithm, and that algorithm generates this function rather than that simple one. Yes, do you agree what I'm doing? So I took that expression, I used the formula that we had in Math 4, I put it here, I multiply everything, the numerator and denominator by cosine x squared, this becomes 1, so I didn't write 1 below there, and this becomes. But what is cosine x squared tangent x squared? Sine x squared. So it becomes 2 sine x squared. What about this one? This in your head, it is sine over cosine. 1 cosine and cosine are cancelled. Sine, cosine is left. Yes? Oh, we don't get that answer. Do you see? No, yes, we get. And then I have minus 2 cosine x squared. Now you see that is the same answer. Why? Because between these two, I factor a minus 2 out. It becomes cosine x squared minus sine x squared. And instead of sine cosine, I write 1/2 of sine 2x. That's correct, and this is the formula for cosine 2x. So it becomes minus half sine 2x minus 2 cosine 2x. And that's exactly there. So the answer is not wrong, but it is a little bit weird. Yes, and the simplification is not good. Yeah, we can also test Wolfram alpha to see what they do. Yeah, just so let us test this Wolfram alpha. This see which one is more powerful. So I think in Wolfram alpha, it is called dsolve or something. Of course, it's an AI. You can just type, but I think dsolve is for differential equations, and I think I can just type the equation there. So I can just write 2 star y prime, and then plus or minus. Oh, what was that? No, that was not my equation. What was my equation? Up there. Minus, so it is y prime minus 2 star y, and then equals to that combination, equals to 5 sine 2x. Hopefully it understands what I'm writing, plus 3 cosine, and then I have 2x. Yes? Let us see if it works or not. Yes, it is more reasonable answer here. So the algorithms are different, and it also has simplified sine 2x, and the 2's are gone, yes? So that's exactly the answer that we got here. So it's more reasonable answer, and of course you get all piece of information here as well. Anyway, it is correct. Okay, so that's the whole lesson, but let us now try to ask your opinion about other things. For example, let me give you this question. What is your opinion about this question? What is this question? How do you solve this problem? So y prime plus 2y. Now these are harder questions. Not computationally, I want you to ask your opinion about that. So if I, on the right hand side, I have this equation. I want to solve this. Okay, then what should I do? Because now, on the right hand side, I do not have a purely exponential function. I do not have a purely polynomial function. I have the sum of them. Okay. And do you remember I said something in the previous lesson, but I didn't complete it there, and that was linearity of a differential equation. So that's extremely important here. I want you to understand the algorithm does not change at all. Okay, because the algorithm is independent of what you guess or whatever. But the second part is just to find a way to guess. If you can, the algorithm works. But what we do here, I would write it as y prime plus 2y equals to 0 again. But then what happens? Yp becomes c e to power minus 2x. But now I want to ask your opinion about this. What do you think I should guess for yp? Because it is clear, if you just guess polynomial, it will not work. Because polynomial will generate polynomial part at most. Exponential one generates the exponential part at most.
So you should do a mix.
Okay, so that is what I am asking you, how you want to mix them up. Yes.
I could just first like find the general form of e to power x and then x squared plus 1 separately and just add them together.
Okay, that is correct. But why is that? Not for all differential equation it works. Exactly the adjective linearity is very important here. And these differential equations we are talking here are linear. So what do I mean by that? So let us say that I want to solve this differential equation, which on the right hand side, how should I write it? I have f of x, but this f of x is a combination of two other functions, linear combinations. What do I mean by that? I mean a constant multiple of a function f1 of x plus another constant, say c2, multiplied by another function like that. Okay. Or if you don't mind, let me take these c's away. What Rasmus said is correct. So he is talking about this way of thinking. You can consider two equations from the beginning. One equation so that the right hand side has only f1 part in it. Yes? And then you guess an answer for this, let me call it yp1. And then you solve the other one alone, I mean without looking at the other one. So you solve this one and let us say that you get yp2. So what you said is if I add them up, it becomes a yp for the original equation. And that is always the case if the equation is linear, in which case it is linear. A linear differential equation is of this form: y prime plus a function of x only at most multiplied by y equals to another differential equation, another function of x. This differential equation of this form is linear. And if you have a linear differential equation, what Rasmus said is correct. Yes?
Can you give an example?
No, we want to prove it first.
Non-linear.
Non-linear, for example, y prime. This is linear. You can compare it with that. But this one is non-linear, for example. Yes? For example, because this coefficient also depends on y itself. So that's a non-linear. But when I write p of x, it means that it is only related to x. If the coefficient here is only a function of x, and this one is also a function of x only, then that differential equation is linear. But if one of these coefficients at least not only depends on x, but also on y or y prime. I mean, if you want, you can write y double prime here. I mean, that, of course, that is not a first order differential equation. So you can write like this: x plus y. For example, this is not a linear differential equation. Okay, so this is something that you need to know. If the right-hand side is the sum of two or more functions, when I say sum, it is also working for difference, then you can solve them separately and find a particular solution for each one of them separately. But then I want to convince you that if you add them up, it becomes a solution to the original differential equation. Okay, if we know that, then we can solve a lot of problems here that are also a mixture of the right-hand side. Yes, so what should we do? When you say that yp1 is a solution, it means that it fits my equation. So it means that yp1 prime plus a yp1 is equal to f1 of x. When you say that yp sub 1 is a solution, a particular solution, it means that it fulfills the equation. And when you say yp2 is a solution to this differential equation, it means that it satisfies my equation, which in this case is the same equation, but the right hand side is f sub 2. So this I know, this I know. I want to convince you that the sum is a solution of the original differential equation, which is extremely simple to see. Why? I have to convince you that if I put this there, it becomes f of x. Let us do that. So I will take this I will take this function and put it in the original differential equation and show that it fits the equation. In other words, I start from the left-hand side of the original equation, replace every appearance of y with this, then what happens? And that's exactly the linearity property that we talked about. So what happens? The derivative can be done separately, and then I multiply this a in, and then I group them in a wise way, meaning that I take this one and that one, and then I take this one with that one, and then what happens? I can use number 1 and 2. If I call this number 1 and I call this number 2, I can use number 1 and number 2. What can I write for this one? I can write f1 of x. Why can I write for this one f2 of x? But if I ask you what is f1 of x plus f2 of x, that is exactly f of x. And that's equal to the right hand side. So as far as you have a differential equation with this property, you are done. So in principle, if I give you this in the exam, this is not one problem, this is two problems. Yes? So you have to consider this one separately and that one separately. But for the general part, you don't need to separate them. So the general part is this. Sorry, I made a mistake here. So this is not yp, this is yh. So yh for both of them is the same. But now I have to split the problem into two parts and solve it, okay? So what should we do? I separate it to two problems. One problem with exponential only, and one problem with the polynomial part only. For this one, my guess is a e to power x. For this one, my guess is a second degree polynomial. I already used letter A here, so let me start with B. B x squared cx plus d. Yes? If you want, you can write yp1, yp2, doesn't matter. Okay, but let us just do it fast, because if I put it y prime here, it becomes the same function, plus 2 times y becomes 2a e to power x. This is supposed to be equal to e to power x. So this means 3a e to the x is e to the x. So 3a e to the x is e to the x. So this means that a is 1/3. So this means that I got my first particular solution, which is 1/3 e to power x. Yes? And now I go to this one. So what is y prime? I put it here, so it becomes 2bx plus c, 2 times y, which is 2bx squared plus 2cx plus 2d. It's supposed to be equal to x squared plus 1. Okay, because this you have experience now, let us do it faster. So 2b should be 1, yes? Between these two, I factor 2x out. It becomes 2b plus c times x, but that should be 0. So this means b plus c should be 0. And then c plus 2d should be 1. Yes? So here I get b is equal to 1/2, c is equal to -1/2. and then it becomes d is 3/4, yes? Yes? Okay, and then what happens for yp2? So yp2 is what? Is b plus c and then d. Okay. Now finally, your final answer will be what? Y equals to the homogeneous part plus this particular solution plus that this particular solution. So it becomes plus 1/3 e to power x plus 1/2x squared minus 1/2 x plus 3/4. That will be the general solution. Okay, we can also test this if it works with GeoGebra. So let us see if it can provide us a good answer. So here I would say it's solve ODE. Okay, and then I have to type it as exponential. So I use the virtual keyboard to the power of x, and then plus x to the power of 2 plus 1. Oh, plus 1 minus what? Minus 2y. I think, oops, I don't know what it is doing anyway. So we don't need to simplify this. I mean, that is better to write it in that way. Yeah, that's correct. I can see that's correct. Because you divide this term by that term, 12s are gone, and e to the power of 2x goes up, and it becomes exactly what? E to the power of minus 2x as we have here. And then you can convince yourself the rest of it is also correct, hopefully. Yes, it's a little bit crazy way of writing. Okay, so that is, for example, this one. Oh, now let me give you another question. I want to wait for you, of course, when the lesson is finished. Yes, we have a little bit of time. So I will give you this. The harder ones, I will talk about that later. But this one is not hard. It is calculationally lengthy, but I want you to do it, okay? So this is the equation. Y prime minus 4y is equal to sine 2x but minus 3 cosine, not 2x, cosine x. So I want to wait for you so that you can solve this. We solve it next time, but I think I typed it here, so that should be your answer, according to Wolfram Alpha. Yes? The answer should be this expression. I don't know. Did you find this answer, Simon? Yes? Make it bigger so that you can see better. This is the solution according to Wolfram Alpha. So it is understandable. So you should have two combinations for sine and cosine with argument x, and two for argument 2x. Of course, I don't know why Wolfram also always separates them, but anyway. So cosine 2x. So these are the coefficients. You need to find 3/17, 12/17, minus 1/10, and 1/5, minus 1/5. Yes? But I will start solving this next time. Any questions? Thank you.